Organization and bus system. Now, what is register organization? It means what are the different types of registers available in CPU and what type of data they are storing. We know that register is the smallest and fastest accessible memory available in CPU. It is always the top of the hierarchy in CPU. Registers are normally measured by the number of bits they can hold. For example, an 8-bit register can store 8-bit of data. 16-bit register can store 16-bit of data, and so on. Now, what are the different types of registers available in CPU? First one is program counter. It always holds the address of next instruction to be executed. Accumulator AC, it holds the data to be processed, intermediate results, and the final results. Memory address register, that is MAR, holds the memory location of data that needs to be accessed. Memory data register holds the data present at location stored in MAR. Memory buffer register is same as MDR, that stores the data being transferred to and from memory to other components. Instruction register always contains the instruction currently being executed. Input register receives the data from input device. Output register holds the data for output device. General purpose registers, for example R1, R2, R3 and so on, can be used to store either data or an address. Now, what is bus system? Bus system, it is single computer bus that connects the major components of a computer system. कंप्यूटर के अंदर बहुत सारे डिवाइसेस हैं, मेमोरी हैं, रजिस्टर्स हैं, मदरबोर्ड में बहुत सारे हमारे कंपोनेंट्स हैं जिनको आपस में कम्युनिकेशन करना होता है फ्रॉम वन डिवाइस टू अनदर, दैट इज विद द हेल्प ऑफ बस. देयर आर मेनली थ्री टाइप ऑफ बस: data bus, address bus, control bus. Data bus is used to carry information, address bus to carry address, and control bus to carry control signals. But nowadays common bus system is used to transfer the information between registers, memories and input-output devices. This is the diagram for common bus system. Common bus system, it has different registers available CPU. It also has memory unit, input register and output register. Adder and logic circuit is also there. Now suppose we have a memory of 4096 into 16 memory words. 4096 locations are there, so we need 12 bits of address. Into 16 means each location of the memory can store 16 bit of data. Now selection variables S2, S1 and S0 are used to select the register which will place the data onto the common bus. For example, if S2, S1, S0 is equal to 100, 100 means decimal 4, so accumulator will place the data onto the common bus. And at the same time, which register will receive the data from the common bus? The register whose LD, load input, is active will receive the data from the common bus. Two registers AR and PC will be of 12 bit because these registers are used to store the address and our address is of 12 bit. Input registers can provide the data that is of 8 bit because the communication between input output devices and memory is byte to byte, 1 byte at a time. Output register OUTR can only receives information 8 bit, least significant bit, from bus to transfer it to the output device. Adder and logic circuit has one input from DR and other is from AC to perform arithmetic and logic operations such as add DR to AC. Add DR to AC means add the contents of data register and accumulator. The result will be placed back into the AR. Similarly, AND DR to AC. AND operation will be performed on contents of DR and AC. The result जो होगा that will be placed on AC. Complement AC means every bit of accumulator register will be complemented, and final complemented data will be stored in AC. This is how common bus system will work. Thank you.